Hi guys, I've picked a few equations here that you would find in the logarithm chapter. The very first equation is a log equation, so let's try to solve this one. The very first thing to notice is that this side has a log plus another logarithm. Now you cannot have more than one log per side, so we need to combine those two logarithms. Now if you remember back, if two logarithms are added, we can combine them into one logarithm if we multiply the arguments. Now the arguments, this one is x, and the argument of this one is x minus 2. So that's what I'm going to do first. I can rewrite this as log base 3 of x times x minus 2. And that equals 1 still. And then I could just distribute that x. So log base 3 x squared minus 2x equals 1. All right. Now, this is one major type of logarithm equation. If you end up with a log only on one side and not on the other, then you have to rewrite it in exponential form. And that's doing 3 to the first power equals that stuff. So I rewrite it as 3 to the first equals x squared minus 2x. So now that it's rewritten in exponential form, it's much easier to solve. I can just subtract 3. I'm bringing everything to one side because I can see that it's quadratic. So x squared minus 2x minus 3. And then I just need to factor that. So that will be x minus 3 times x plus 1. Then I'm going to set each of those equal to 0. Let's take it up here. So x minus 3 equals 0, and x plus 1 equals 0. So I get x equals 3, and also x equals negative 1. Now the final thing to do when solving a logarithm equation is to check your answers to see if they're extraneous. Basically, we have to take each of these numbers, plug them in for the x's up above, and make sure that we're not getting a negative or a 0 written next to the logarithm. So if I plug in 3, both there and there, I will be just fine, because right in the first spot it'll just be a 3, and in the second spot it'll be 3 minus 2, which is 1, and both of those numbers are perfectly fine. So x equals 3 is a solution. Now, if I check the same kind of thing with x equals negative 1, so I'm going to have to put the negative 1 into here and also into here, well, that's a problem, because in the first log it's going to be negative 1, and in the second log it's going to be negative 1 minus 2, which is negative 3. If you even get a negative in just one spot, it's no good. So x equals negative 1 is an extraneous solution, and we're just going to put a big X through it. So that is not one of our final answers. So just x equals 3 would be the final answer. Okay, now let's move on to equation number 2. This is one of the harder examples of an exponential equation. The very first thing with this one is this first term right here, 3 to the 2x plus 1. I can break that apart and rewrite it as 3 to the 2x times 3 to the 1. Now the reason why is because let's think, if we had 3 to the 2x times 3 to the 1, we know that when the same base, which is the 3, is multiplied together, that we are allowed to add the exponents. So if I was working backwards, this would become 3 to the 2x plus 1. So I just wanted to show you where that came from. So I'm going to get rid of this now. All right, now moving on, I'm going to just rewrite the rest of this equation. Minus 7 times 3 to the x plus 2 equals 0. And I'm going to do one more rewrite. The 3 to the first, I'm just going to put 3, and then I'm going to keep this 3 to the 2x minus, and then the rest of it. Plus 2 equals 0. Now, I rewrote it this way for a reason. If you look through this equation, you can see in the first term you have 3 to the 2x, and in the middle you have 3 just to the x. Anytime the first exponent is double the middle exponent, this is going to be a quadratic form, and we can work on it the same way we would work on a quadratic with factoring and all of that. One thing that sometimes makes it easier for people is this little substitution step. Let's rewrite this one more time, and this step is optional. If you just see how to do this with the factoring, you don't have to do this step. But I can change this to 3 to the x squared minus 7 times 3 to the x plus 2 equals 0. And then you can pick any letter. I'm just going to pick y, and let it equal that middle portion that had the exponent. Let y equal 3 to the x. So then when I go through and substitute the y in place of every 3 to the x, it's going to look like this. 3 times, so I'm going to put y in right there. So 3 times y squared minus 7, and then I'm going to put the y in again, so 7 times y plus 2 equals 0. Now you can see that this is just a normal looking quadratic. Let's rewrite it without those times dots. Okay, so this is what we've got. Now from here, we want to just factor this like a normal quadratic. I'm not going to review how to factor right now. This is just going to be 3y and a y, and it'll need to be a 1 there and a 2 there, and they both need to be negative. So that's factored. And then the two solutions for the y would be y equals 1/3 and y equals 2. Now remember, these are the solutions for y, and y was just something that we made up for the problem to make it easier. The y was it was 3 to the x, so I'm going to rewrite both of these as 3 to the x equals 1/3, and 3 to the x equals 2. Now 3 to the x equals 1/3, that solution is the easier one. That would just be x equals -1, because 3 to the -1 is the same thing as 1/3. So this is one answer for x. 3 to the x equals 2. That's not going to be a nice solution because there's no power that would make 3 to that power exactly equal 2. There's no integer answer. So for that one, we could just rewrite that in logarithm form. So this part would become, we could just write log, and then it would be base 3 of 2 equals x. And, you know, if you have a calculator, you could punch that in and see what decimal that is. For right now, I'm just going to circle that and leave it written as log base 3 of 2. So these would be our two solutions. With an exponential equation, you don't have to check the answers at the end. There won't be any extraneous solutions. Okay, and then I have one last problem for you guys on the next page. This is a short one. It says, given that ln of 5 approximately equals 1.6094, find the ln of 0.04. The trick to this is to rewrite ln of 0.04 as the ln of a fraction. 0.04 is the same as 4/100ths. And then if I reduce that fraction, that's the same as 1/25th. Now, we've been told information about the ln of 5. So 5 is a key number. Well, if you look at your fraction, it's 1/25th. So I could even change that to the ln of 1 over 5 squared. And then it would be even better if the 5 wasn't in the bottom. So I could rewrite that as ln of 5 to the negative 2. All right, now if you remember, there's a property of logarithms that says this negative 2 can come down in front of the log. So I can rewrite this as negative 2 ln of 5. And we're almost done because now we know that the ln of 5 is 1.6094. And then that's just going to be times negative 2. And you could pull out your calculator and do this. I'll show the work for it because I don't have my calculator right here. So 1.6094 times 2. Let's see what that is. 8. Okay, so it's going to be that, and it's going to be negative. So this right here would be the final answer to this problem. They love to throw in these decimals, like 0.04. The trick to those is just to always rewrite them as a fraction, the way that I did right here, 4/100ths, because then it'll reduce, and from there you'll be able to do more things with it, with the information that they gave you. And that's it.